Oh, well. Mm, so, there we go. All right, so we have exam 2 is Friday via my math lab during class time, right? Just like last. Okay. So exam's Friday during class time. You don't come to class. It's online, right? But it'll open up. I know online it says it's opening Thursdays because I haven't changed it yet. Okay. It'll open up right when class starts, and I forget how much time y'all got. I think it was like 70 minutes or something. I know it's not a 70-minute class, but we do 70 minutes, so it works for both Tuesday, Thursday, and Monday, Wednesday, Friday classes. Okay. Y'all cool with that? Most of y'all made A's on the last exam. Y'all should be able to make A's on this one. All right. Make sure you make an A on this one so you don't have to take the retake again because it's written and much more difficult. Okay. Um, so today we had the request of doing the practice exam. So if y'all want, we can start at the beginning and work our way to the end, or start at the end, work our way to the beginning. How do you want to do this? Start at the beginning. Okay. All right. So to get as far as we can, I'll do the calculus and I'll leave the arithmetic parts for y'all to fill in. Okay. Find the derivative. So they mean dy dx, also known as y prime. So y prime, we'd have to use the quotient rule, right? So we have the bottom times the derivative of the top. The derivative of e to the x is just e to the x. And we have minus the derivative of the top times, no, sorry, the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared, right? And based on these answers, it looks like they want you to do some factoring maybe. No? Anyway, what's that? We got the 2x e to the x squared. It has to be either b or d, right? B or d. Let's do some factoring. Let's see, we have 2, we'll do 2 e to the x plus 1 minus 2 e to the x. I'm going to factor out this 9 e to the x here. All right, y'all follow that step, just the algebra. I saw this shows up twice, so I just factored it out. And then those cancel. Yeah, exactly. Those cancel, and then we just have 1 times 9. So e to the x plus 1 squared. So that would be what? B. Boom. All right, any questions about this one? All right, and this is the calculus part, right? The derivative of e to the x is just e to the x, so pretty easy there. So that's number 1. Let's look at, and stop me if you have questions, all right? Otherwise, why the exam is so easy? Was it? Oh, that sucks. mean, most of y'all got A's, like the median score on exam 1 was a 90. You know? Maybe you're just having an off day. All right? Math anxiety is a thing. Here we go, find the derivative. So we got a function times a function. So we have to do the product rule. So we have the first function times the derivative of the second plus the derivative of the first function times the second. Of course, they're going to want you to multiply the 3, 5, and do this. And if you wanted to, you could factor out what, a 5. So this would be a 3x plus 2. No, let me see. How would they write that? They would want you pull out a 5 and an x, and then put your e to 3. Right? Yes. I don't know. I just did problems like 23 through 35 in the last class, and I didn't see any of those. So if there are, they're in the first half of the exam. So we'll find out. Right? We did a lot of those in the last class, though. So if you check out the YouTube video, you'll see lots of examples of that. I don't know how they want this. Yeah, see, they pulled the, I guess it would be C here. I don't know. I like to put the exponential after that, but it's all the same, right? So it's what, is that 2, 3? All right, cells in thousands of a new type of product are given by S of t, where t represents time. Find the rate of change of cells at the time when t equals 8. Okay, so here we could do, there's only one variable, t, right? So you could use your prime notation or your dot notation. Either way, it's the same thing, right? So f prime, all right, we're talking about the derivative with respect to time, or you could call it s dot, right? Dot is specifically for time. Right? Same thing here. So the derivative of 300 is 0. So we have negative 70e to the negative 0.2t times the derivative of the stuff. Right, so this is negative times negative is a positive. What's 0.2 times 70? 20% of 70, 10% would be 7. So 20% would be 14. Yeah. Yeah, 14. Thank you. So that's S prime. So they want to know what S prime is when t equals 8. So plug in an 8 for t. Boom, done. Does this make sense? Right? These are the easy ones. 2.862. 26. 26. All right, and there is software out there, right? Like you have Desmos for one thing. I'd use like something like I use Wolfram Alpha. You can always type in f of x and then type in derivative of f and it'll give you the derivative. Like you should be using software to check all your work. The math in here is simple, but clearly you have to do it quickly for the exam. So you don't really have time to check your work. But if you use software, you can easily type it in. All the math we do, the software will do the math for you. It'll find a derivative of anything. Just probably type it into Google, derivative of, and type in the function, and it'll tell you what it is. Right? Find you some software, learn how to use it, check your work. It'll also help you learn the material much more quickly. Teachers don't want you to do that because they don't want you to just type it in and get the answer and learn nothing. But while you're trying to learn, right, if you check your work each time, you see you made a mistake, and then they'll show you the steps. It's the fastest way to learn. To make the most use of your time is to use the stuff that they say don't use because they don't want you to cheat, or if you cheat in a smart way, right? right? Use it to help you learn, not to avoid learning. All right, let's look at number 4. Assume the total revenue from the sale of items is given by R of X, while the total cost to produce X items is C of X. Find the number of items that should be manufactured so that the profit is a maximum. So the profit is R minus C. We need to maximize this. Remember, maximums and minimums occur when the derivative is 0, right? So we need to find the derivative of P. Well, what is P? Let's see. R is 23 natural log of 7x plus 1. And then C of X is X over 4. So that's P of X, right? So P prime is going to be the derivative of P with respect to X. So P prime, we have a 23. The derivative of natural log of stuff is 1 over stuff times the derivative of the stuff. Derivative of X over 4 is just be 1/4. So we need to set this equal to 0 and solve for X. All right, so what is this? What is 23 times 7? This is 161. I'm going to move the 1/4 over here. I'm going to flip both sides. All right, multiply both sides by 161. And then I'm going to move my 1 over here. And then what? Divide by 7? Whatever that is. So no, yeah. I don't know. Assuming I didn't screw that up. 161 times 4 minus 1 divided by 161 times 4 minus 1 divided by 7, approximately 91.86. So that's the critical number, right? That's where local mins and local maxes occur. We don't know if this is a minimum or a max. They want us to be a maximum. Well, by intuition alone, I could tell you it's a maximum. We're talking about profit here. We know it's not a minimum. The minimum profit is 0, right? You can always have a minimum of 0. So this clearly has to be where a maximum is happening, right? You could do first derivative and second derivative tests to check, but if you're just trying to get the answer as fast as possible, you want to use that intuition, right? Okay. If you want, we could do like every other problem, and if we get to the end, we can come back and so that we cover the whole spectrum here. Click the reset button in the upper right corner. Click draw f of x. Complete the sentence below. Oh, this sucks. Okay. When the tangent line is horizontal, the graph of f prime intersects the x-axis or the y-axis. Number 7 next. Okay, we'll go to number 7 next. So what do they want us to do? Y. When the, what is the question? When the tangent line is horizontal, the graph of f prime. So when that sucks too. Okay. So there, the tangent line is horizontal, right? Well, there is no graph of f prime here, right? This is the graph of f. All right. The graph of f prime, right here it says 0, right? So when the thing is horizontal, that's where f prime is 0, right? F prime of x is 0. Okay. That's the y value, right? Here's your x, there's your y. The graph here, f prime starts off positive, then it's 0, and then it's negative. So the graph of f prime, if it starts off negative, and then it's 0. I'm sorry, it's positive. Yeah, positive, positive, then it's 0, and then it's negative. So positive, 0, and then negative. All right, so along that line, the y value is 0. Yeah, does it? That's what we want is some, there we go. So that's the actual, weird. Where's the rest of it? Okay, there. So that's the graph of f prime, all right? So if we go back where this thing is horizontal, right? So when this thing is horizontal, that means the derivative is 0, right? The slope is 0. So that's why the y value here is 0. So that's where it's intersecting the x-axis, right? So let's see. Oh, I guess it doesn't tell you, huh? So, I mean, we could see from the picture here, right? When the slope is 0, right, that's when f prime is 0. That's where the y value is 0. So that's where you're crossing the x-axis. Do this. Okay. So what was the next request? What if slope is 0 and the line is horizontal? It wouldn't cross x. If the slope is 0, then f prime is on the x-axis because the y value is 0, right? If the y value is 0, that means you're on the x-axis, right? So if f prime is 0, that means the graph of f is crossing the x-axis. Vertical, yeah, if you're looking at a vertical line instead of a horizontal line, there isn't one here. That's because a vertical line f prime would not be defined, right? The slope doesn't make sense for a line that goes straight up and straight down. Or was it number 7, I think, is the request? So remember, what did we skip? Number 6. So if we have time, we'll come back to number 6. R represents revenue, thousands of dollars. X represent the amount of spending on advertising in thousands of dollars. Find the following for R of X. So we have this closed interval here between 0 and 21. Find R double prime. Well, R prime is going to be negative 3x squared plus 96x. So R double prime is negative 6x plus 96. Find the point of diminishing returns. Remember what that was? That's if we have something like this, something like this. So the whole time here, we're increasing, right? But right here, we're switching from here, the rate of increase is increasing. So here, f double prime is positive. We're concave up. Here, f prime is still positive, right? But here, the second derivative is negative, right? That was the point of diminishing returns. We like it when our profit is going up like this. When it starts to do that, it means it's plateauing, right? So we need to know what this point is. That's where second derivative is 0. So we just set this equal to 0 and solve for x, right? So x is 96 over 6. That's your point of diminishing returns. Y'all remember that? Kinda? All right, the math is easy. Second derivative set equals 0. Again, the business stuff you have to remember, new vocabulary. And this is going to be in thousands. Boop, boop, boop. What was that, 7? All right, we're going to start doing the odds till we get to the end, and we'll come back. we'll do what, starting at 6, right? Is one we skipped. Make sure we cover the whole spectrum. Maybe I should get the questions in here too, right? The daily cost of producing X high performance wheels for racing is given by the following function, where no more than 100 wheels can be produced each day. Right, so that's why we have 0 to 100. What production level will give the lowest average cost per wheel? Well, this is cost, right? Boom, this average cost, right? That means we need to find the average, right? Remember, C bar is C over X, right? So if we divide everything here by X, we would have 0.05 X squared minus 5X plus 173. This kind of stuff was what I saw was missed the most on the last exam, at least the one that I graded, the retake, right? Missing that and not doing this. They were just working with the cost. It's difficult because like the derivative gives you averages, you know, in a sense. So trying to figure out marginal average cost and all that. So here's C prime. We want to minimize average cost. So to minimize it, we need to find the derivative. So we'd have what, 0.1 x minus 5. Set that equal to 0. So let's see. X would be 50. 50 hundred. Right? So since X is in hundreds, right? Where is it? The daily cost? No, X is just X. All right. So yeah, X equals 50. That's either going to be a minimum or a maximum, right? Really, the maximum cost is infinity. I mean, if your workers are like bad enough, like the cost would be an infinite amount. So we know that this has to be a minimum by intuition, right? There's no maximum cost. So knowing that, boop, they want to know what the actual cost is, the minimum average cost. So you'd have to plug this back into the average cost function, right? Plug that in for X. Then you have the actual minimum average cost. We good? All right. So that was 9. Let's look at 11. Where is it increasing? Well, from here to here, from 3 to infinity, right? Round bracket, not square bracket, because at 3, it's not increasing, it's 0, right? You have to have a round bracket here. What was that, 9? Where am I? That was 11. All right, 13. Another easy one. Where is it decreasing? Well, here. So we'd have to do a round bracket at 5, because at 5 it's 0. And then at 12, we could do a square bracket, because once it gets to 12, it's still going downhill. It depends on, that's questionable whether you want round. Yeah, well, you can see at 12, like, let's say here's 12, right? If it was doing like this, where at 12 it was 0, I would put a round bracket. But this thing's looking more like this, so, you know, depends on how you want to interpret decreasing at a point, right? At a point, nothing is happening, right? Points are infinitely small. So I would say it's a square bracket. I'd say it's decreasing at 12, but some people might say at 12 you can't increase or decrease, right? Because you're at the end of the line. See, they did a round bracket. They're all round brackets. So hey, now you know. 14, the next request. So they want you to say that this is round, because at a point you can't increase or decrease. There is no to the right of it. So that's how they interpret that. All right. So what was it? 14 was the next request. Which one would we just do? This was 13. All right, let's look at 14. I guess we'll switch to evens now. Somebody needs to write down the ones that we've done. Is this it? Find the location and value of each local. It says local extrema, but it shows arrows. Yeah, the arrows just mean that this goes on forever. So really, there's only local min, right, at 3 minus 2. That's going to be a minimum. That's it. There is no maximums because this thing goes up forever. That's why the arrows were important. If the arrows weren't there, then you'd have to look here and here at the endpoints and check to see. Right, those would obviously be maxima, right, if the function actually ended. But it goes forever, so there is no local max. 14. We skipped what, 13? We'll go back to odds here. We'll go to 15. Yeah, that's the minimum at that point right there. Oop. Find the largest open interval where the function is increasing. Well, it's increasing where the first derivative is positive, right? So first off, find out where it's 0 and then test your intervals. So the derivative would be, let's see, 2 over 4 is a half, and then minus half. So this is 1/2 times x minus 1. You can write it either way you want. So where is this equal to 0? We want to figure out where it's greater than 0, but where is this thing equal to 0? When x is 1. So here's 1. That's where the first derivative is 0. So we kind of test these intervals over here. It's either going to be positive or negative in these two places. So if we check out, let's say 0, prime of 0 would be negative 1/2, which is negative. So it's decreasing over here. Let's check out this interval. We'll plug in a 2 here. We would have what? 2 over 2 minus a half. That's 1 minus a half. Positive. So it's increasing over here. So the answer would be from 1 to infinity. Right? Round bracket, because at 1 it is 0. Right? Right here is where f prime is equal to 0. Everything to the right of it is greater than 0. Yeah, it's right here. Plugged in the number 2, and I got that it's positive. Right? So these were my test points. Determine the location of each local extremum. And then I guess they want us to figure out if they're minimums or maximums also, right? So the extremum happened when the derivative is 0. So here's our derivative. Right? We need to set that equal to 0. If we divide everything by a negative 3, we got this. Factor this dude. Let's see. To get a 12, we need a 4 and a 3, right? So either x is 3 or it's 4, right? So are these minimums and maximums? Well, let's do the second derivative test. That's fastest. Let's be a negative 6x plus 21. So there's the second derivative. Let's check 3 here. This would be negative 18 plus 21, which is whatever it is, it's positive. So at the number 3, this thing is concave upward. That means that's a minimum. Now let's check at 4 here. We'd have negative 24 plus 21, which would be negative. That means it's concave downward. So that means that this thing is a maximum, right? By the second derivative test, it tells you concavity. Yeah, the critical numbers. Yeah, and it tells you the concavity at that point, so you know if it's which way it's opening. Yeah, if it's positive, it opens upward, which tells you that it was a minimum. Uh, 19. Use first derivative test to determine the location of each local extrema and the value of the function at that extrema. All right, the extrema occur when the first derivative is 0. So we need to do the product rule here. First function times the derivative of the second plus the derivative of the first times the second. So we could factor out an e to the minus x here. And what do we have? We have a 2 minus 2x, right? Negative 2x and a 2. And let's pull the 2 out, right? There. So where's this 0? This is never 0. 2 is never 0. So the only way this thing is 0 is if x is 1. Okay? So that's, it could be a minimum, it could be a max. They don't ask us, I guess here they do ask us to find out if it's a minimum or a maximum. We could do a test to see if it's a min or a max. But the point, we'd have to plug this back in, f of 1. We plug it in over here because they want to know what the value is of the function. So let's get that part. We'd have 2 times 1 e to the minus 1. So this is 2 over e. So we know an extrema happens at this point, right? So it has to be one of these. But is this a minimum or a maximum? Well, they said use the first derivative test. Well, we could do the second derivative or the first. Let's just do the test points right here. Here's our critical point at 1. I'll put it up here. That's where the first derivative is 0. So let's see what the first derivative is here and here, right? Well, at 0, our test point, where's our function? Here's our thing. We'd have 2, 1 minus 0, e to the minus 0. This is just 1. This is 1. So this is 2. It's positive. So over here, we see the function is increasing. Right? Here's the number 1. Let's see what it happens now. If it continues to increase, it's an inflection point, right? Right? It could increase and then increase. My guess it's going to decrease over here. So let's find out. Let's plug in a 2. We have 2 times 1 minus 2 e to the minus 2. This is a positive number. This is a negative number. So this whole thing is negative. So boom, that tells us this thing is going, first it's increasing and then it's decreasing, right? So at 1, that tells us that it is a maximum. Does that make sense? Instead of the second derivative, we just looked at the first derivative. It's increasing and then it's decreasing. It's 21. Yeah, I always post the notes after class. Might take a while to get the YouTube video up. For some reason with this laptop, every time I upload a video to YouTube, it takes a little bit longer. Now it said like 2 minutes. At this point, it's taking like 30. And it's not my internet. It's just I need to like clear my cache or something. I guess in the web browser. And I know about this stuff. I don't want to do it because then I have to enter in all my passwords again. All right, so find f double prime at the point 1. All right, well, f prime, the derivative of e to the stuff is e to the stuff times the derivative of stuff. We would write as 6x e to 3x squared minus c. So f double prime, looking at this, we have to do the product rule. So we have the first function times the derivative of the second. The derivative of e to the stuff is e to the stuff times the derivative of stuff. So that's the first function times the derivative of the second. Now we have the derivative of the first times the second. So we could, let's see, I can pull a 6 out of all this nonsense, and I'd still have a 6x squared, and then plus 1, that's e to the 3x squared minus 3, right? 6 times 6, x times x, and that guy, and then 6 times. So there's our second derivative. So f double prime at 1 would be 6 times 6 plus 1. E to the 3 minus 3 is 0. That's just 1. So this would be 7 times 6, or 42, right? We're just replacing x with the number 1, right? This would be e to the 0. Anything to the 0 power is 1. Am I going too fast? Yes? Okay. We'll slow down. So it's just e to the stuff, right? The derivative of e to the stuff is e to the stuff times the derivative of this stuff. The derivative of this is 2 times 3 is 6x, right? That's the derivative of 3x squared. And then I just moved this to the front because it looks prettier. To get the second derivative, we did the product rule. We have two separate functions. So we take the first function and multiply it by the derivative of the second. And we already know the derivative of this, right? It's e to the stuff times the derivative of that stuff. And that's the first half of the product rule. The second half says take the derivative of the first function and multiply it by the second. So the derivative of 6x is 6, and then we just keep this stuff. And then I just did a bunch of factoring. I saw that this happens in both of these, so I pulled it out to the right. And I saw that both these terms have a 6, right? This one has 2 6s, this one has 1 6. So whenever I pull the 6 out of all this to the left, I have a 6 times a 6, and right here is 6 times a 1. So there's 6 squared, and over here is just a 6, a single 6. So just quick algebra there. And then we just replaced x with 1. They say find f double prime of c, and they could have just said find f double prime of 1. I don't know why they have to throw in a c and then an x. This is nonsense, right? So you just replace x with 1. So 3 times 1 squared is 3. 3 minus 3 is 0. E to the 0 is 1. 1 squared is 1, so it's just 6. You just get a 6 times a 7. Got it? All right. 21, 23. Find the largest open intervals where the function is concave upward. It's concave upward when the second derivative is positive, right? So we need to find the second derivative. The first derivative is 4x cubed minus 18x squared. The second derivative is 12x squared minus 36x. So to find out where it's positive, first we'll find out where it's 0, and then we'll test the intervals around that. So if I factor out a 12 here, factor out a 12x, right? This would be an x minus 3. So either x is 0 or 3. So over here at 0 and 3, this is where f double prime is 0, right? So we need to check and find out here, here, and over here. So we need to do 3 test points, right? So we do f double prime of say -1. So here's my double prime here. So -1 squared is a positive. So this would be, so over here, it's positive. Let's check inside of here. We'll do, we'll pick like a 1 here. What did I do? We'll pick 1. So that would just be 12 minus 36, which would be negative. And then let's check what 4, f double prime of 4. That'd be 12 times 4 squared minus 36 times 4. I don't know what that is. 12 times 16, and 92, and then 36 times wherever that is, it's positive. Okay, so we got our critical points. Well, I should call it critical points. So we found out where the second derivative is 0. And then we check the intervals. So where it's positive would be negative infinity to 0, right? This right here. And 3 to infinity. So what? Because we have two places where it's 0. The second derivative is 0 here and here. So that busts us up into 3 different intervals we have to check. Makes sense? So this dude, boom. Find all critical numbers, see if they're minimums or maximums, or neither. All right, so the critical numbers happen when the derivative is 0. Here is our derivative, right? Set it equal to 0. We could factor out a 3 here. Factoring out a 3, and then doing this stuff, we got an x and x, minus, minus, 4, and 4. So x equals 4 is our only critical point, right? We need to know if this is a minimum or a maximum, or neither. I think the fastest thing is to do the second derivative test here. So it'd be a 6x minus 24. So f double prime at 4 would be 24 minus 24, which is 0. Wah, wah, wah. So that doesn't tell us if it's concave up or down. We don't really know, right? We have to do our first derivative test. Right? If it was positive, we'd know that it's a minimum. If it was negative, we'd know it's a maximum. It tells us it might be a critical point or something weird. So let's do, here's 4, right? So let's test like 0 in our first derivative. So f prime of 0 would be 48, which is positive. That means our function's increasing. And let's pick out maybe like 5. F prime at 5. Let's see. Now let's do 10. 10's an easier number. 10 squared is 100 times 3. And 10 times 24 is 240. So this is what? 60 plus 48 is positive. So this thing is positive and then positive. So what we're looking at is it's increasing, it's 0, it's increasing. So that means it's an inflection point. So it's neither a minimum or a max. All right, we got an inflection point going on. Y'all got that? Yeah. All right, 27. This one looks easy. Find the location, the absolute maximum. Well, it's right here. That's the maximum, right? It's at 0, 2, 4. Right? See these dots here? Right? That means the graph ends there. Okay, so it's 0, 4. That one is easy. The next one. Find the absolute extrema within the specified domain. So we have a closed interval here. That's key, right? So the extrema happen at the critical points or at the endpoints, right? So the first derivative here would be a -1 over x plus 2 squared, right? Because that's really just x plus 2 to the -1. So if you do the power rule, you get the minus sign and then subtract 1 from the exponent. So that's the first derivative. If you set it equal to 0, this is never equal to 0, ever, right? You always just look at the top. 1 is never 0, so there's no critical points. But the extreme value theorem says that on a closed interval, there's always a minimum and a maximum, right? So if I'm looking between here and here, no matter what this thing looks like, there's got to be a max and a min. In this case, they're there and there. Even if I had just a straight line, there's no critical points, but the max and the mins occur at the endpoints. So the endpoints here are going to be your minimums and your maximums. To see if they're a min or a max, just plug them in. Find out what f of -4 is and f of 1 is. See what those are. Whichever one's bigger is the max, whichever one's less is the minimum. Does that make sense? Yeah? Okay. Implicit differentiation. Okay. These are easy, right? So we're finding dy dx, all right, or y prime. So we'd have 3x squared plus, here we're going to do the product rule. We have the first function times the derivative of the second plus the derivative of the first function times the second. Now the derivative of y cubed would be 3y squared, and the derivative of 8 is 0. All right, so we're trying to find y prime. So we just take all this and move it over here. So negative 3x squared minus 6xy minus 3y squared. Oh, you know what? I screwed up. Hold on. This was good. When I took the derivative of this, yes, 3y squared times the derivative of y. I forgot to do the chain rule there. Right? So now we collect whatever has y prime in it. These two things, right? I just factored out the y prime. The rest of this stuff we move to the other side. So y prime is this stuff divided by this stuff, which we could easily simplify, right? Everything has a 3 in it. So this is negative x squared plus 2xy over x squared plus y squared. I just divided everything by 3. Now they have the answer. Yeah. Yeah, they put the minus out front here. So it'd be b. Boop. They put the minus out front. So let's see, that's 31. Let's look at 33. We got 1 more minute. Think we can do this? We can do this. Assume x and y are functions of time. Evaluate dy dt. I'm going to call that y dot, derivative with respect to time. So via implicit differentiation, I would have 3x squared x dot plus 3y squared y dot equals 0. All right. They tell us here that x dot is -3, and they give us an x and a 2. They want us to find y dot when this is true. Well, y dot is going to be a negative 3x squared x dot, right? I'm just moving this over and then dividing by this. 3's cancel out. They give you x dot, they give you x, and they give you y. Just plug those in. We're out of time. All right, can y'all handle it? Y'all can handle it. Good luck, y'all. I'll see y'all on Monday.